In this video, we're going to talk about the average rate of change of a function. So the rate of change of a function is how much is it changing and in what direction is it changing. So the way we define this for a function, say we have a function f of x, let's just say it's equal to x or something like this. So we want to measure how much y is changing in terms of how much x is changing. So in other words, if x changes by some fixed amount, how much does y change? Okay. So the average rate of change takes two fixed points and measures, okay, what is the how much did the function change on this interval? So let's look at an example here. So let's look at the point, maybe let's look at 2 points on our graph. Say 1, 1 and 3, 3 in this case. Okay, so these are both 2 points on the function f of x equals x. So we want to know how much does y change based on the corresponding x change. So the way we're going to write this formula for the average rate of change is going to be the change in y divided by the change in x. Okay. So there's a couple different ways this is written. Sometimes we write these with a delta, which looks just like a triangle. Delta is the popular symbol in math and science for change. So we would write delta y over delta x. And if we have arbitrary x and y points, right? So say like we're looking at the average rate of change between the point x1, y1 and x2, y2, kind of like we were making formulas for the distance formula and the midpoint formula. Then this would be y2 minus y1 divided by x2 minus x1. So the change in the y, in other words, the distance between the y values, divided by the change in the x, in other words, the distance between the x values. And now that we have this function notation, we could also write this as f of x2 minus f of x1 divided by x2 minus x1. Okay. So on this function, on this example that we have here, this would be the average rate of change, which we sometimes abbreviate as AROC, A-R-O-C. Right? This is going to be equal to the difference in the y values, which is 3 minus 1, divided by the difference in the x values, which in this case is also 3 minus 1. So this is 2 divided by 2, which is 1. Okay. So you might recognize this as the slope of this line, and that's exactly what this is. For a line, it is exactly the slope of the line. Okay. Let's look graphically at what we are doing here. Okay. So because this is the actual formula for the slope of a line, if we have 2 points, say x2, x1, y1, and x2, y2, okay, up here, the function can be doing whatever in between. Okay, maybe it looks like this or something. When we're looking at the average rate of change between these points, we're simply drawing a line through them. Like what the formula is doing is it's drawing a line through them, a straight line, and it's finding the slope of that line. The slope meaning the steepness of the line, which is exactly this formula right here. The change in y divided by the change in x. So it's not really concerned about everything that's happening in between. It's just worried about the beginning and the end. So that's why it's the average rate of change. It's taking the rate of change at every point on this graph and taking an average of them. There's also the instantaneous rate of change, which is the rate of change at a specific point, but that requires calculus. Okay, so with the tools of algebra, we're limited to just looking at the average rate of change, which is finding the slope of this line. So if you do this for any 2 points on a line, it's going to correspond to the slope of that line. So let's do another example here. Now that we can kind of see what's going on graphically, let's find the average rate of change on the interval -1, 2 for f of x equals x minus 1 squared. Okay, so this is typically how the problems will be stated. Find the average rate of change on some interval for this function. So I'll just draw a quick picture here so we can see what's going on graphically. We'll get into actually how to graph this kind of function in a different video. But this is going to be the graph of x squared shifted 1 unit to the right. Okay, so it's going to look something like this. Not exact, just doing a quick sketch here. So the points might be a little bit off. But we can see what the values, we need to find what the outputs at the endpoints here are, right? So at, we need to know what f of -1 is and what f of 2 is, right? Because this is part of our formula. It's f of the f of x2 minus f of x1, which in this case would be f of 2 minus f of -1. So let's first find f of -1. So we're going to plug in -1 for x and evaluate. So we have -1 minus 1 squared. So -2 squared, which is 4. Okay. So we have a point at -1, 4. Try to line this up with the graph here. And then we have f of 2, which is going to be 2 minus 1 squared, which is 1 squared, which is going to be 1. So we have a point at 2, 1 right here. Okay. So what we're really doing when we're finding this average rate of change is we're imagining that there's a line between these 2 points, and we're finding the slope of that line, which is the steepness of a line. So in general, lines have the equation y equals mx plus b, where m is the slope and b is your y-intercept. Okay, so that slope is exactly what we're finding here. So we can see in this case it should be a negative slope because the line is going down, it's decreasing. Right? So we have all the values that we need for the average rate of change, right? We need to do f of 2 minus f of -1 divided by 2 minus -1. And we have all of these values. So let's do 1 minus 4 divided by 2 minus -1. So this is going to be -3 divided by 3. Which is just going to be -1. Okay. So one thing to keep in mind here, one very common mistake is to reverse the order of either the x or the y values, the top or the bottom. It doesn't actually matter which order you do them in as long as you're consistent on the top and the bottom. So if you do f of 2 minus f of -1, you need to do 2 minus -1 on the bottom. You could do f of -1 minus f of 2, as long as on the bottom you do -1 minus 2. If you reverse them, the order on the top versus the one on the bottom, you're going to end up with the negative of whatever it is you're looking for. In other words, a line in the opposite direction. So it doesn't matter what order you do them in. It's like the difference between finding the average rate of change between -1 and 2 versus between 2 and -1. It doesn't actually make a difference. As long as you're consistent on the top and the bottom, the math will work out. Okay. So this is telling us that between -1 and 2, on average, the y value is changing by -1 for a unit change in the x value. Okay, so that's one way we can think of this value, is that y changes by -1. In other words, the graph goes down 1 every time x goes over 1. So we can think of it as a unit change in x, and then the output here, the average rate of change, is how much you're changing on the y-axis.